All right, this is lesson 21 in topic 2 of IM Algebra 2. This is still rational equations. This is going to be part 2. So they do want you to solve each equation mentally. I'm okay if you don't, because this is the idea of cross multiplication. Again, it is a longer method that let me rephrase that. There is a longer method you can use. Cross multiplying is a shortcut. I would like to show you the longer method and then show you how the shortcut works. When you have a fraction, this is like saying x divided by 2. When we do the opposite to cancel, the opposite of division is multiplication. So we'd multiply both sides by 2. So this leaves us with 2x over 2. The 2's cancel and just leaves you with x. 2 times 3 is 6. And we solve that 4. Then we repeat the process because we need to get rid of this fraction that has a denominator. So we'd multiply both sides by 4. That leaves us with 4x equals 6 because these 4's cancel. Then we divide both sides by 4 and we get x equals 3 over 2. Okay, which is also 1.5. Now if I were to rewrite what we began with, if you notice, when we got to this step in the prior one, that can also be caused if we multiply these two numbers by these two. So it's called cross multiplication because you are going across the equal sign. You're taking the numerator of one fraction times the denominator of the other, so 4 times x, and that's going to equal your other numerator times the other denominator, so 3 times 2, which is 6. I'm actually going to put 3 times 2 and then put 6 underneath it so you can see where it's coming from. Once you get to this step, it's the same, so it's going to be solved using the same steps as right there. And you still get the same answer. This just saves you 1 step, 2 step, yeah, so it saves you 2 steps. And you can just go straight across. So if we apply that same method, and I always start with my top left, so 3 times 6, it's 18. And make it equal to my top right. I don't normally write the 1. You can write the 1. It doesn't really matter. There is nothing to solve after you get to this point. 18 equals x, that's it. Now this one is a little different because of the x squared. You're going to end up with x squared equals 4. If you are not familiar with this, to get rid of something squared, like the opposite that we normally do, the opposite of squaring something is square rooting. Because we physically wrote in the radical, the square root symbol, you're going to get 2 answers. The square root of 4 is 2, but it could be a positive 2 or a negative 2. That's what that sign means. If you want to write it out, this is the same as saying x equals 2 and x equals negative 2. Be very careful. If you put it into a calculator, it will probably only give you the positive version, but you do have to account for the negative as well. This is true because negative 2 times negative 2, also known as negative 2 squared, is going to equal that positive 4. And then if you have a positive 2 times a positive 2, that also gives you that 4. The same idea is going to apply here. 2 times 8 is 16. X times x is x squared. Even though it's on opposite sides, it doesn't matter because if you set it up differently, in that you do x squared equals 16 because you like starting over here first, that's fine. As long as you are multiplying the correct numbers, you're good to go. When we take the square root of 16, we'll get 4, and again, you have that plus or minus, and that is your x. In 21.2, Noah's going for a boat ride. Still water. This means you're not moving. There is no current. It's just literally sitting water. The boat can travel 8 kilometers per hour. In the river, it takes them the same amount of time to go upstream 5. So the same amount of time to go upstream 5 as it does to go downstream 10. So if the speed of the river is r, they want to know how long it's going to take to go upstream and how long it's going to take to go downstream. So if you think of going upstream, that means you're going against the current. If you're going downstream, you are going with the current. And I am sorry if you hear my toddler screaming. Apparently she's getting put down and she does not want to have it this evening. All right, really quick, just a reminder, distance equals your rate times your time. And you can maneuver this equation to be like distance divided by rate equals your time, because that's what we want to solve for is time. So when you're going upstream, we know we're going 5 miles. You're going to divide by the rate of the river. This 8 is just the rate of the river on its own. You have to account for the fact you're going upstream, so you're going against the current of the river. So this is still water, this is the river. If you're going upstream, you're trying to go this way and the water's pushing back on you. You're not going to be able to go that full 8 kilometers per hour, so you have to subtract the rate of the river. You're going slower. So if the river is going 1, you're really only going 7. If the river's going 3, you're really only going 5. The downstream, similar in that you're going 10. Again, the still water is 8. But the rate of the river is actually going to help you. This is like a tailwind when you're in track or a tailwind when you're flying a plane. But if you start going this way and there's wind behind you, it's actually going to make you move faster. If the river is going an additional 2 kilometers per hour, you're really going to be able to go 10 kilometers per hour. That's what this is talking about. So in question 2, because we know it takes the same time to go upstream 5 kilometers as it does to go downstream 10, we can take those equations that we just created. So you have the still water minus the rate of your river, and then the still water plus the rate of your river. And we can cross multiply these. Now I like that we're doing this in the same part where we learned about cross multiplying, because you can see the distribution that's going to happen. You have 5 times 8 plus r, and I really do apologize for the toddler if you can hear her screeching, and then 10 times 8 minus r. When you have this, you're going to end up distributing. So 5 times 8, 5 times r. So 5 times 8 is 40, 5 times r is 5r, and you do the same with this. So you're going to end up with 80 minus 10r. Now, the nice thing about this is you don't have any squareds to worry about, so the nice way to solve it is if you move your r's to one side and your constants to another. I do not like negative numbers in front of my variable, so I'm going to start by moving this 10r. And you can do this all in one step. You could move the 5. You could switch which you add first. It doesn't matter as long as the final answer is the same. If you change the order or the number you're moving, your middle steps are going to be a little different, but you should still get the same answer. So I'm going to end up with 40 plus 15r because of this 5 plus 10. This 10 cancels, so I'm just left with 80. Now I'm going to move my constant over to the other side. I'm going to get 15r equals 40. To solve this, you divide by the number in front of your variable, and you're going to get r equals 2.3. 40 divided by 15 is 2.6. Oops. Okay. And that 6 is repeating. So I'm going to say 2.7. So the rate of the river is going 2.7. What this tells us is that when you're going downstream, when you're going upstream, the rate that you're going is 8 minus that 2.7. So you're really going 5.3, which is why it takes so long. When you're going downstream, because it's helping you, you're going to have 8 plus that 2.7. So that's the 10.7. And that shows you it's approximately twice as, okay, let's reword this. When you're going downstream, you're going about twice as fast as upstream, which makes sense because you're going twice the distance as well. Now, looking at 21.3, I'm going to be real straightforward. I do not like it. I'm also not huge into the trades. Like, I'm not very knowledgeable about this. But if you are someone who wants to be like an electrician or something, I would definitely look up a video for this. Just know that it's going to tell you what your resistance is, and you're plugging in those numbers to help find patterns. That's all I'm going to say about that. Let's do some practice problems. All right, so for the practice problems, when you see something that has nothing underneath, you can just pop a 1 underneath there and still cross multiply. Because you're multiplying by 1, it's not really going to change anything that you're multiplying. So I have this multiplied is going to equal this. and it kind of looks like scissors or boomerang. It's not very nice, okay? This x minus 1 times x plus 2, some of y'all might like to do the box method or the area model. So I'm going to have x minus 1, x plus 2. Where you put the x minus 1 doesn't matter if you do it up top or across the side. X times x is x squared. Negative 1 times x is negative 1x. 2 times x is 2x. 2 times negative 1 is negative 2. Now you're not quite done because you have to combine like terms, which are these two because they both have that x. Negative 1 plus 2 is just 1, so you can write the 1, you don't have to. I tend to write it when I'm teaching so that you can see where this one is coming from, and it helps keep track of counting, because sometimes if you don't put the x, then you will lose track of it. Give me 1 second. My cat is on my daughter's toy. Okay, the musical playmat has been turned off. So anyway, you want to keep track. And sometimes if there's not a 1 in front, you do forget about it, and then you don't combine the terms properly. So this is going to be my x minus 1 times x plus 2. Make sure I have the right numbers here. And that's going to equal these three things times 1, which is not going to actually affect anything. Now to solve this, you want to move everything over to one side. You want it to equal 0. That's the general way to solve it. You can also look though, because they're both an x squared. If you move one x squared over to the other side, they're both going to cancel, and then you're just left with 1x minus 2 equals negative 4x plus 3. Now we could proceed in moving everything to one side to solve, or we can solve it how we've been doing, where we get our x's on one side and our constants on the other. It honestly doesn't matter. Later on, we won't be able to do this when we get to the more quadratic functions, but for now it does still work. So I can add my 4x to both sides. I get 5x minus 2 equals 3. Add 2 to both sides, 5x equals 5. Divide by 5, I get x equals 1. So that's good. I am going to go back to this step right here and show you another way to. All right, quite frankly, I don't remember if I told you I was going to do it another way. You cannot use the quadratic formula because you're not going to have this x squared, and you could potentially factor. Yeah, okay, so you can factor. If you're going to factor, it has to be 0 on one side, and actually that's going to be true for the quadratic formula too, so it's good practice. If you're going to do it that way, you're going to want everything, here I am already adding it in my head, you're going to want everything to one side first. So I'm going to add 4x to both sides. 1 plus 4 gives me 5. But then instead of moving this 2 to the other side, I'm actually going to move the 3. So I get 5x minus 5 equals 0. Now this would be what we want if we're going to do the quadratic formula, or if we're going to factor. In this situation, if we're going to factor, they both have a 5 in common, so I can pull a 5 out front. 5x divided by 5 leaves me with x. Negative 5 divided by 5 leaves me with negative 1. And then I can solve this. So x minus 1 equals 0. And I get this. Now this is not necessarily a good opportunity to use factoring because my mind goes this way. But if this works for you, do it. And this is really good practice to get set up for the quadratic formula later on. All right, so we got another cross multiplication with my very shoddy circles. Okay, 4 times 4 plus x is going to equal 5 times 4 minus x. A common mistake I've been seeing with my students is make sure you're multiplying both of these numbers by the number in front. So 4 times 4 is 16. A lot of them get that. Do not forget that you also need to do 4 times x. Same thing goes here. 5 times 4, yeah, they do great. 5 times negative x is negative 5x. Do not forget these two. Same idea as what we did up here, where we're going to get everything to one side. And I do not like negative numbers in front, so I'm going to move that over. Again, you can do it all at once. You don't have to. It looks like I might be getting a fraction here. And I am not going to convert that into a decimal because I don't think that's going to be a pretty number. But that is your answer, 4/9. Okay, the next one confused me a little bit to start, but we can definitely do it. It's still cross multiplying, but again, when you multiply by 1, nothing changes. So you're just going to have x times x plus 50 equals 60 times 2x plus 50. So this would be a good opportunity to pause it and try this one on your own. Don't even worry about what the rest of the words say right now. Just go ahead and solve this, and then we can talk about it from there. If you need to follow along, you can. Otherwise, again, pause it and try this on your own. So x times x is x squared. 50 times x is 50x. Then you get 120x plus, is that 3,000? Give me 1 second while I confirm that that is indeed, might be missing a 0. Nope, 3,000. Okay. Because of this x squared, I am going to want to move everything to one side so I can either factor or quadratic formula. So I'm going to move my 120. That leaves me with x squared minus 70x equals 3,000. Another common mistake is people will just stop here and they'll start solving it. Nope, it needs to equal 0. So I'm going to subtract this 3,000 to get to the other side. Now, normally I put it underneath where it matches because they have to be like terms. There is no constant on this side, so the 3,000 is just going to be there. And it's going to equal 0. You can factor. I know when I'm thinking about it, I don't necessarily want to figure out what is going to multiply to 3,000 and also add to negative 70. I don't want to. So this is a good opportunity to use the quadratic formula. Quadratic formula, and again, there is a song for it. If you go online to YouTube and you look up the quadratic formula song to Pop Goes the Weasel, that's one I know. But this is the quadratic formula. And the reason I put parentheses around it is more so for when you're putting it into the calculator, because there are some calculators where if you don't put a parenthesis around this and your b value is negative, and you square it, it's just going to square b and then put the negative in front, which might give you a non-real calculation. So it's just safer to use parentheses around it. Your a value is what's in front of your x squared, which is technically going to be 1. Your b value is what's in front of your x, so negative 70. And your c is your constant, so negative 3,000. And then you're going to plug it into this equation. This plus or minus means you have two options. You have negative 70 plus your 70 squared minus 4 times a times c. But then you will also have the same thing, but a minus in between these as well. Again, the exact same numbers. You're just subtracting whatever's under the square root instead. Oh, there she goes again. I don't know why she's so angry. Okay, so then you can go ahead and put these in the calculator, and it should pop out two answers for you. I'm so sorry, you couldn't even see it. So again, they're the exact same. This is with a positive, this is with a negative, well, a plus and a minus. Go ahead and put these in the calculator, and then it should pop up with your answers. All right, so apparently I did know what it was going to factor to, and I thought I was wrong. When you plug this into the calculator, you're going to get 100 and negative 30. If you were to factor it, it would look like x minus 100, x plus 30, but that equals 0, and then you have to actually break it into pieces to solve both of them. Either way, you would still get the exact same numbers when you solve it. And what they really wanted us to look at, because I told y'all to ignore it, I was ignoring it too, was that it was equal to what was up here. We got that. To show that it's not at 0 or negative 50, you're going to look at your denominator. When you have x and x plus 50 in your denominator, think about what number you can never divide by. You can never divide by 0. That will give you an undefined answer, and you can't have that. It literally won't calculate it. So what you do is you check to see what looks like it might be a solution or what would make your denominator 0. So you have two pieces. If x equals 0, because if this is 0 and 0 plus 50 is still 50, but 0 times 50 is 0. So that doesn't work. If you have x plus 50 equals 0 and you solve for that, you get x equals negative 50. So this would be negative 50, but then this would be 0. And when you multiply those two, that's also 0. So when you solve this, whatever's in your denominator cannot be 0, so those x values do not work. All right, last practice problem. Kieran jogs at a speed of 6 miles per hour when there are no hills, so it's completely flat. He plans to jog up a mountain road, which will cause his speed to decrease by r miles per hour. Think about if you were running, are you going to go faster up a hill or slower? Which expression, represents the time it takes him to jog 8 miles up the mountain road? Just keep in mind if you were going down, you would increase your speed because you'd go faster. So distance equals rate times time. We are solving for time, so we divide both sides by rate. So it looks like this. So our time is our distance, which we know he's going 8 miles. So we just want an 8. So that eliminates A and C. Then we have to decide, is he going faster or is he going slower? Well, if you're running up a hill, you are going to go slower, so you're going to decrease that rate by r miles per hour. So it is D.